Hello, everyone. Great news for you because I am just so excited about the fact that this channel is growing. And I never would have imagined just a week ago, even 2 weeks ago, a month ago, that this was actually going to just blow up in the way it's blown up. We almost have, it's right now, it's 11:27 in the morning, Eastern Standard Time. And I already have almost, according to the last count, I did almost 300 subscribers. So thank you to all of you for that. I'm going to make a video today introducing you a little bit and discussing. Don't worry, I'm not going to sell you anything. I know some people have said, oh, he's trying to sell. I'm just going to comment on my book and give you some problems here so that you can see. So a couple years ago, I wrote a book because I was getting a little bit aggravated with the lack of standards in a lot of the American, particularly. I haven't seen others, but a lot of American math textbooks at the algebraic level are just appallingly bad. Actually, some of them even have mathematical imprecisions, mathematical lack of mathematical reasoning in some of their definitions. I've seen some books, for example, that confuse things like mass with weight, for example. So this book is called A Monograph of Algebra. I wrote it several years ago, and it's online. It's available on Amazon, but I'm going to share with you in this video. I wrote a chapter on fractions, algebraic fractions, and I'm going to post the fractions. There are several cases of fractions. This actually comes from, so the page number, if you have the book, from page, where is it here? 54, page 54. And it's talking about case five of how to reduce complex algebraic or numerical fractions to simple or singular fractions. So I'm going to first tell you the kind of the principle behind it. The rule is basically that when you want to reduce complex fractions, a complex fraction, just to be clear, in case you don't know this, is when you divide a fraction by another fraction, and they kind of like look vertical. So when you're dealing with fractions of the form a over c divided by d over b, what you do is you all know from division of fractions, when you're dividing fractions, you have to multiply by the reciprocal. So just because it's written this way doesn't mean anything. It's just a different style. So you take the numerator here, which is the top fraction, which is a over c, and you can rewrite it as a over c, whatever a over c is, multiplied by the reciprocal of the bottom here. So it's d over b, which becomes b over d. And if you know from multiplying fractions, when you multiply fractions, you multiply the top right across, AB, and then you multiply the bottom over CD. You can always rewrite these, by the way, as a regular division and then crisscross, cross multiply. When you're dividing fractions, two fractions, you can always cross multiply. Now that's not mathematically a speed, that's just a shortcut. It's not really a trick. But the real mathematical principle is that you're multiplying by the reciprocal. So if you had something like, let's say, 2/9 divided by 1/2, you can rewrite this as 2 over 9 divided by 1 over 2. And then it looks like just a regular division problem. So some textbooks write it like this. I like to write it the vertical way because I'm old school and I like to represent math in different ways, but they're really equivalent. The reason we use this format, by the way, the complex fractions, because sometimes it's more convenient when you're dealing with, particularly when you're going to see today, algebraic fractions. So the first one that I'll put here is, I'm going to put the problems from my book, a few of them, not all, there are hundreds of them. First, I want you to try them. And then you're, of course, going to pause the video when you try them. And we're going to see if you are actually correct. So the first example is, I'm just going to number them here. 7 1/4 divided by 8 1/2. Number two, so this is just a numerical one, right? We always start numerical. We'll have a over b divided by m plus n. Give that one a shot. All right, so these, and again, these are all from my book, The Monograph of Algebra, on the chapter on fractions. The third one we'll do is a over x plus a over y. I want you to simplify these into a single fraction, by the way. That's the exercise in my book. And we'll do a fourth one. Let's do a plus b over c divided by x minus m over n. All right, I want you to pause the video, right? Have a look at these. I'll put them up in case you want to copy them on your paper. And please do not use a calculator. I mean, I know it's accepted. I don't have anything against calculators, by the way, but just try to think of them. Try to do it mentally. At least the first one, when I say mentally, I mean like first think about it, then work it out on paper. And then for the rest of them, work it out on paper. Do not use, I mean, how is a calculator going to help you with number two, for example? Unless you have, you're using some kind of software, which I don't encourage you to do because software does not really teach you anything except how to input things. But I do ask my students to show understanding. All right, so if you've paused the video, let's go through these. All right, the first one is 7 1/4 divided by 8 1/2. Those of you who had the answer, if you had the answer, I'm going to put it on the right side, 29 over 34. You are correct. And why is that? Because when you have mixed numbers, by the way, my book has all the answers for every exercise. So you can always check every single, it's just the examples are worked out, but of course the exercises themselves are not. That's when I gauge students' understanding of something. So when you have mixed numbers, and mixed number, remember, is a whole number with a fraction, you actually have to convert it to an improper fraction. An improper fraction means the numerator is larger than the denominator. 4 times 7 is 28. 28 plus 1 is 29 over 4. Divided by 8 1/2. Well, again, if you multiply the denominator by the whole number, that gives you 16. 16 plus 1 is 17 halves. And I always check. In this case, we can't really do it. I always check, though, from the top and the bottom if we can reduce anything. Because if we can reduce a fraction, that makes your final calculations a lot easier. But unfortunately, we cannot do that in this context. So we now have, so basically, this is what you're dividing. And now you have 29 over 4. And since we're dividing, we multiply it by the reciprocal, which is 2 over 17. Right, so we have 29 over 4 divided by 17 over 2. And I can reduce this to, the 2 goes into the 4 twice. So now I have 29 times 1, which is 29, and 17 times 2 is 34. And we can no longer further reduce this, so we're done, basically. All right, so if you got that correct, that means we're on the right track. All right, let's do the second one. The second problem I gave you was a over b divided by m plus n. Well, Here we have a simple division. It's the top number is, those of you who had, I'm going to put it on the right side, the answer. If you had A over Bm plus Bn, you are correct. Now, technically, the bottom, the denominator here, I can factor because it has a b, but I didn't get into, in this particular chapter, I didn't get into factoring. So I'm just going to leave it like that. But technically, you could do b parentheses m plus n if you know about the distributive property. But I haven't discussed that in this part of the book. So we have a over b divided by the reciprocal, right? So we're going to, it's divided by m plus n, but we're going to change it to multiplication by the reciprocal. So the reciprocal, this number here, m plus n, is really, remember, when you want to convert any expression into a fraction, you just put it over 1 if it doesn't have a denominator. So the original is a over b divided by m plus n over 1. Well, m plus n over 1 becomes 1 over m plus n as the reciprocal. And now you're ready to do this. A times 1, a. B times m plus n gives you this, or b parentheses m plus n, it's okay, whichever way. All right, so some of you have been exposed to this, some of you have not, and I've seen a lot of students at the calculus level, they're still not getting this right. Basic stuff like this, not getting right. I don't know where they're going to school or what textbook they're using, but I'd be curious to see what tech. Well, I was told by one student, he said, we don't use textbooks anymore. Right, not even, I mean, I know with the technology there you could use PDFs, of course. I'm not saying you have to have a physical copy, but it just seems strange to me that you'd have no guidance at all on these things. The other problem that I gave you, those of you who had for number 3, I'll put it on the right as usual. If you had for number 3 the answer AY over XY plus A, you are correct. And again, because our original problem says A over X plus A over Y. And the top number is really, again, we want to convert it to a fraction, so you just put it over 1. It makes it easier sometimes if you just put it over 1. So we have A over 1 divided by, and then this is a mixed number, actually. This is what I was looking for here. This is actually a mixed number. X could be any number, like let's say 5, A and Y, 5.5, for example. So you multiply to convert any mixed number to an improper fraction. You multiply the denominator by the whole number, right? So this, I'm going to use red. This goes to X, Y, and X, right? Which is really XY or YX. It doesn't matter. I'll just put X first. X times Y. And of course, plus, right? Then you add this, A over Y. And now you're ready. A over 1 divided by, now this is really a 1, X over XY over 1. So the reciprocal, remember you flip this, right? So we're going to multiply that because we're dividing, we multiply the reciprocal. The reciprocal is now Y, right? Y times 1 is Y divided by XY plus A. And now you have a beautiful expression. A times Y becomes this. XY plus A times 1, any number times 1 is that number or expression. It's a mathematical law. So you have AY divided by XY plus A. Isn't that lovely? It's all about rearranging things and using the laws of math to help you. All right, the fourth problem, fourth and final problem. The problem, those of you who said as a final answer, in the top, you should have A, C, N plus B, N over CNX minus CM. So now you have the original problem was A plus B over C divided by X minus M over N. And what you've got here is you have a mixed number in the numerator. So just like we said before, you multiply the denominator here is C, represented by C, multiplied by the whole number, which is represented by A. So C times A becomes CA, or I like to go alphabetical though. So that becomes AC plus this, right? B over C. Right? And there's really a 1 here, so it's really AC. If we, to simplify our lives, it's really AC plus B over C, right? Because C times 1 as the... So now you take the bottom, N times X. Well, N times X is NX, right? So this is divided by NX, and then you have minus here, so minus, instead of adding, minus M over N. And we could put that over N as well, because it's really NX over 1, but so now you take this number, circle it in white, you take this number here, AC plus B over C, and multiplied by the reciprocal. The reciprocal of NX minus M over N is N over NX minus M. And now you just multiply. This times this becomes AC times N is ACN. And then you have B times N, that's plus positive, right? So BN. And then the same thing on the bottom. C times NX is CNX. And then C times negative M gives you negative, right? Because a positive times a negative gives you negative CM. Let me know in the comment sections down below how many of you got all of them right, or how many you got correct. If you didn't get them all right, tell me how many you got correct. Tell me if you've seen problems like this before at your school, what your impression is, if this was easy to understand, just let me know. So this is called simplifying. This is from my book, case 5, of to reduce complex fractions to singular or simple fractions, simpler fractions, right? There are other examples that I give, but we don't have time, of course, because I have other classes to teach today. If this was helpful, please let me know. And again, I encourage you, if you're interested in math, we've got a lot to say on this channel. I will be doing a video probably, if I could do it, I'll do it today, but if not, at some other point, I made a video of how I became a mathematician, but I wanted to get a little bit deeper into sort of what my experience was as an undergraduate and how I became the person I am today, where I studied, I spent some time in England for the greater part of what I did my master's degree in England, Imperial College, but I did my undergrad in the United States. I was at Columbia University as an undergrad. And so there's a lot to say, and I'm always sharing math, and happy to have you as my subscribers. So thank you all, and we'll see you soon.